All right, so we are going to talk about coupled equilibria, which we have talked about before. We have talked about before in the section on equilibrium, but we're going to look at what three examples of how we can couple equilibrium to describe certain processes. And these are the three examples that we're going to look at. How we can dissolve an ionic solid with a strong acid, or dissolve a sparingly soluble solid by using complex ion formation. And then we're going to look at an example of coupled equilibria in our environment, specifically in the oceans. So for this video, we're going to look at the first example where we can dissolve precipitates. So there's two methods that we can dissolve compounds that are sparingly soluble, right? One way we can do this is by adding a strong acid that will react with either the basic anions, like hydroxide ions, or ammonia in the compound. And a second way is we can add a Lewis base that will react with a metal cation that's formed from this dissolution reaction. So let's look at the examples more closely. So the first example is, how can we dissolve zinc hydroxide in a strong acid solution? So here's the dissolution reaction of zinc hydroxide. It can take place in two steps. So first, I'm sorry, not in two steps. The dissolution reaction of zinc hydroxide is as follows, where zinc hydroxide is a solid, we put it in water, we get zinc ions and hydroxide ions. But this is a sparingly soluble reaction. So if we couple it with a strong acid that we're representing by H+, so any strong acid, it can neutralize the hydroxide ions that are formed from this dissolution reaction. And by coupling them together, this is our overall reaction. So we have zinc hydroxide solid in acid will release the zinc 2+ cations in water. So thinking about this coupled equilibria, how do we explain the dissolving or the dissolution of zinc hydroxide using Le Chatelier's principle, right? What do we do here? How does Le Chatelier's principle apply to this coupling equilibria? So pause this video and think about what has happened here. See if you can pause this video and think about what's happened here. So essentially, right, if we just have zinc hydroxide in water, if we were to look up the KSP, we'll probably see that it's a small number. So it's sparingly soluble. But if we add a strong acid, because it's neutralizing these hydroxide ions, it's essentially decreasing the amount of products, specifically the hydroxide ions. So according to Le Chatelier's principle, if we disturb this equilibrium by decreasing the amount of hydroxide ions, it's going to shift the reaction to the right. And by virtue of doing that, we are increasing the solubility of zinc hydroxide. And we're increasing the solubility by dissolving it in strong acid. Right? And so this is a summary of what I've just said. Since the strong acid neutralizes the hydroxide ions, this step one or dissolution reaction is going to shift to the right. And this is increasing the solubility of zinc hydroxide.